This is section 10.4, inscribed angles, starting on page 727. Number 1, find the measure of angle B. Angle B is an inscribed angle. An inscribed angle will have its vertex on the circle, and it will be equal to half of its intercepted arc. So its intercepted arc is where these two sides touch the circle, which is 60 degrees. So the measure of angle B is half of 60 degrees, so it is 30 degrees. Number 3, find the measure of arc WX. So to find this measure, first we have to find its inscribed angle, or angle WYX. After we find that, since this is half of this, this will be 2 times that. So the measure of arc WX is equal to 2 times the measure of the inscribed angle WYX. So to find WYX, anytime you have a triangle whose has a side that is the diameter, then it's going to be a right triangle. Okay, basically because the inscribed angle is half of its intercepted arc. Its intercepted arc is 180, and half of 180 is 90. Which means that the two acute angles must add up to 90. So, measure of angle WYX is equal to 90 minus my other acute angle 57, which gives me 33 degrees. So if that's 33, let's substitute that in. So the measure of WX is equal to 2 times 33, or 66 degrees. For number 5, find the measure of angle H. The measure of angle H, this angle, and the measure of angle G will be the same, because both of them intercept the same arc here. So if two inscribed angles intercept the same arc, the measures are equal. So we can set x equal to 2x minus 54, subtract x from both sides, add 54 to both sides, and x is equal to 54, which is all we need because the measure of angle H is x, so that's equal to 54 degrees. Let's take a look at number 7, writing a 2-column proof. If RT bisects SU, we want to prove that this triangle is congruent to this triangle. So we need to get some sides congruent, some angles congruent, so that we can prove the two triangles are congruent by side, 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 or side, angle, side, or angle, angle, side, one of those methods. So the first thing, we're going to state our given information and see what this leads us to. So if RT bisects SU, that means that they split each other in half. So RT and SU bisect each other. SU and RT are diameters of circle V, because if two chords bisect each other, then those chords must be diameters. So based off of that information, we can say that SV and VT are congruent because those are both radii. It's half of the diameter. So half the diameter here and half of the diameter there. So we now know that these two sides are congruent. We're also going to state which angles intercept which arcs. So SRT bisects arc ST, and SUT bisects the same arc. Okay, so we're just stating what an intercepted arc is. So by definition of intercepted arc, those angles intercept the same arc. Since they intercept the same arc, SRT will be congruent to SUT. So inscribed angles of the same arc are congruent. We go on to say that RVS and UVT are congruent because those are vertical angles. Vertical angles are always congruent. And now, in our two triangles, we have a triangle where an angle is marked here, an angle is marked here, and the side is marked over here. So this side is non-included between these two angles. The included side would be this side. And the same goes for this other triangle. We have an angle, and a non-included side. So that makes the two triangles congruent by angle, angle, side. Angle, angle, side. The side is non-included. On number 9, we need to find the value of x. Okay, so we're given our diameter, which means that this is going to be a right angle. Remember, an inscribed angle whose intercepted arc is a semicircle will always be a right angle. If this is a right angle, then both of these angles have to be 45 because it's an isosceles triangle. So these two angles have to be congruent, and 90 divided by 2 is 45. So to solve for x, we set 2x minus 5 equal to 45. Add 5 to both sides, and divide both sides by 2. On number 11, we want to find the measure of arc DH. So DH is our intercepted arc. Our inscribed angle is half of this arc. So if this angle is half of this, and if I multiply this by 2, now I'll have the intercepted arc. So the measure of DH is equal to 2 times 81, or 162. For number 13, to find the measure of angle P. The measure of angle P is equal to half of its intercepted arc, which is this arc here, NQ. Now to find NQ, we need to subtract this arc and this arc from 360, and that will leave me with the measure of this arc. So the measure of NQ is equal to 360 minus, let's see, 120 and 100, so 220, which would be 140. And we're going to substitute that in up here. So we're going to take half of 140, and final answer is 70 degrees. For number 15, we need to find the measure of GH. So GH, notice if I continue that arc to here, I would have a semicircle, which is 180 degrees. So I just need to subtract this arc from 180, and that will leave me with the arc that I want. So subtract arc HJ from 180. Now HJ, its inscribed angle is 20. So the inscribed angle is half of the intercepted arc. Therefore, the intercepted arc is 2 times the inscribed angle, which would give us 40. And if we substitute that in, we get 180 minus 40, and our answer is 140 degrees. For number 17, find each measure. Find the measure of angle R. So R intercepts arc ST. We also see that Q intercepts arc ST. So I have two angles that intercept the same arc, therefore they are congruent, and the measure of angle R is 32 degrees. Okay, we'd use that same principle here to find the measure of angle A. So angle A intercepts DC, and B also intercepts that same arc. So I know that B and A are congruent, so I can set 5x equal to 7x minus 8. Solving for x, subtract 5x from both sides. 2x minus 8. Add 8 to both sides. 2x is equal to 8. Divide both sides by 2. X is equal to 4. Now, to find the measure of A, we need to take this one step further and substitute in. So A is 5x, where x is 4, and 5 times 4 gives us 20 degrees. So I'm going to have to stop it there, and I'll put the rest up later.